Great. Thanks. I'm Nicolae. And let me just start off by saying thank you to Matt for having us and to Shutterstock for hosting us. We're really happy to get to come here and tell you a little bit about what we've been working on for the last little while. So over there is my co-founder, Kareem Amin. And the two of us for the last little while have been working on a product we're calling Clay. And in this talk, I'm going to do two things. First of all, I'm going to tell you a little bit about serverless and what serverless is, how it fits into the world of programming and what that sort of new paradigm is. And then I'm going to tell you about Clay and how we think that serverless is going to really dramatically change how people program and how Clay is going to speed up the ability to create software more broadly. So a few years back, I went to talk to the Flatiron School to a bunch of new developers. And my message to them was, you know, programming is this beautiful thing conceptually, right? Like, it's amazing when you get something up and running and it works. But the truth of the matter is that the day-to-day experience of programming is often just completely miserable. And that really what programming is about is a lot of grit, right? Like, the message was, you know, there's all these annoying parts of programming, and that's what you end up hitting, that like some people stop, but other people keep going, right? And the message to them was, you're not really a programmer until you've like wasted a week of your life or days of your life looking for like a missing semicolon. And there's a bunch of parts of programming that are annoying, like getting set up in your environment, right? Like, oh, the database doesn't work. I don't understand how to like use this API. There's no documentation. I hit a bug. There's no Googleable information about this bug. I'm stuck, right? Getting random things to work together. So all of these sorts of issues in programming are part of what take away from some of that beauty and some of that potential experience of what creating software could be, and also keep a lot of people out of the practice of creating software. So one way to approach programming is just to be like, all right, I'm just going to be like really cool-headed, starting now. I'm just going to like work through everything. And another way to improve programming is to revisit some of like our assumptions around what the tools that we have available to us to program are. And so with Clay, our long-term vision is to make programming a lot more enjoyable and to address a lot of the issues that we feel frustrated by in our day-to-day coding experiences. And what Clay is today is we think of it as the fastest way to build, share, and remix microservices to make awesome software. So I think in the blurb we sent out for the meetup, we kind of described it as a sort of Heroku for microservices for AWS Lambda combined with a GitHub aspect. And I'll explain that to you as we go through it. But first, let's talk a little bit about serverless. So I'm gonna give you a high-level overview and assume that most of you have either some familiarity with serverless or none at all. And what we see with serverless is that it's sort of a new abstraction level, essentially, right? The promise of serverless is that you don't have to think about servers anymore, right? Like, I don't need to think about the machine. I don't need to SSH into a server somewhere. I can actually just write a function of code and have it run and not have to think about how it scales or what's happening under the hood. And that's sort of an increase in the abstraction level, right? The promise is that it takes away a lot of the things that we do in the DevOps world today. And so serverless manifests itself in the world today as these different platforms. So in 2014, Amazon launched AWS Lambda. And the idea was that you could write a function of code. Initially, it was a JavaScript node function. And you could just deliver them that little building block, just one function of code. And they would take care of running that function for you. And you could call it on demand. So we'll go through a little bit what the actual core pieces of serverless are. And then a few years later, Google entered into the market with Google Cloud Functions. And similarly, Microsoft entered with Microsoft Azure Functions. And these platforms look pretty comparable to each other. Amazon has a head start, so they have a bunch more functionality around it. But they're all sort of seeing that this serverless paradigm is very compelling for programmers. And you know, if you look at something like Amazon's last AWS reInvent event, they talked a lot about serverless and about Lambda. And it looks like that's where their mind share is going. So what are the benefits of serverless? So as I mentioned, the sort of promise, right, is just code it. You just write a function, you ship it up to the cloud, and then it just runs and it scales, and I don't have to think about what's happening under the hood. I don't think about servers. I don't think about SSHing into machines. What operating system is it running on? I just write a function in the language of my choice, and then it runs. The other big core concept of serverless is this idea that it's event-driven. So in the case of Amazon, for example, you're able to say, hey, when a new record comes into my database, I want to call this Lambda. So I can essentially set up an event-based rule. And there's a big event hub in Amazon that you can hook into. So like every time someone uploads a file to S3, which is a file storage service on Amazon, I can say every time someone uploads a file, I want to trigger a generate thumbnail Lambda that's going to take that image and resize it. And so the model changes a lot towards this sort of rule-based, event-driven programming where you essentially have hooks into different events that are happening in your system, and then a pipeline of Lambda functions that act on those events and the data that was passed. The other big aspect of serverless is that you only pay when the function is actually run. And so that's a very interesting and compelling use case for all sorts of reasons. So in the world we live in today, right, we're used to paying for servers and having to keep them up 24/7 or for however long we want, and we're billed by the hour that this server box runs. In this new world, I just ship them the code, and I don't pay anything until I actually invoke that function. And then I only pay for the unit of time that the function actually runs. And so this is interesting for any application where most of the time the server is, for example, just sitting idly there and not doing anything. In the case of Lambda, you're not paying anything while it's not doing anything. You only pay when it actually spins up and runs. And this is interesting also because it incentivizes you to be very aware of how long each of these little functions you write take, because you can see exactly like, oh, it ran for this many seconds times this cost. This function cost me this much dollars every time it runs. And so there's this incentive to actually make your code more performant and to see which specific functions in your sort of pipeline or code system are the ones that are costing you money. And the other promise is that it scales seamlessly, right? So maybe you have an application which for some reason is idle all the time, and then all of a sudden there's this like huge, massive traffic spike, and normally you'd have to like think about, okay, I need to spin up more servers, and then I need to turn them off during the idle times. Lambda takes care of that all under the hood, where as more people start using that function, it just scales invisibly to you, and more Lambda instances of your function just get spun up seamlessly, so you don't have to think about the scaling up and down of that particular function. And then the big other thing that happens with all of this is that it encourages modularity, right? So now as I start to think about, okay, like if my code base is just a bunch of little functions, how do I actually make functions that make sense, are modular, can be easily used? And this is really, serverless is really part of the broader move to microservices in general. It's kind of an enabling technology for a sort of practice that people were already doing within their companies, which is to say, hey, let's just break up the problem into lots of small pieces, and you go work on that problem, and I'm going to assume that your little microservice works the way we agreed, and I'm going to go over here, and I'm going to work on my microservice, and you're going to assume it works that we agree, right? And that's how people are building software at a lot of larger companies. And there's lots of benefits to that because it just makes the problems easier to reason about. And also, you might build something that actually gets used all over the place, and now it's just a little microservice that has a lot of reuse and reusability. And so there's lots of benefits, but then there's also problems when like a function is your main building block, and now you get into a case where Uber, for example, they claim they have thousands of services within their internal code base. And so the question is, then how do you code in a world where you all of a sudden have thousands of microservices that you need to be keeping track of, where you have relationships between these microservices, right? Like when there's a bug, where in this like flow of function blocks are the issues. So there's a whole new tool set that we're going to need for this world of microservices, and new potential and new issues to solve as well. And that's kind of what we see ourselves doing at Clay, is that we're trying to build tools you're going to love and tapping into all these benefits for this new era of serverless development. So what changes in the world of serverless development? And that's going to lead us into talking a little bit about Clay. So let's talk about the way the world is today. So if we think about how we share code today and collaborate on code, GitHub and NPM are sort of the de facto tools we use in the Node community. And really, if you think about what GitHub is, it's pretty much just Dropbox for your code, where you have a folder, and there is some like additional like merge functionality and things like that. But at the end of the day, really, it's just pretty much like a hosted folder where we're all dropping in code. And so if you think about that, really what it is, it's a bunch of static files, a bunch of dead files. So that when, for example, I come to this repo here, which is a library to pull up who is information, a node library to pull up who is information. Really what I'm looking at is essentially a folder of files and some README documentation that I have to scan and try to understand, okay, how do I install this? Okay, I can use NPM. All right, what does it return? So I give this example as something that I actually experienced when we were early on in building Clay, where I said to myself, okay, I'm going to make a microservice on Clay that's a whois microservice. And I ended up actually having to go to 3 different whois packages on GitHub because I would download it, install it, try to run it, and be like, oh, this doesn't do what I thought it was going to do. It returns me data in a different format than I expected. And so there's not a lot of feedback here, right? There's some documentation, but you don't get a lot of feedback. You don't get to actually play with it. And then I have to download it, and then I have to, if I want it to be available, I have to spin up a server and deploy an application. So that's the old paradigm that we're currently in. So again, can't really try it out before installing it. Sometimes I might not even be able to get a package running locally. There might not be a package to do something I want in my language, so maybe there's a great whois package in Node, but there's not a great whois package in Go or in Ruby, for example. And these packages can't really be backed by a database in any meaningful way, right? So there's no way, right? We have this like dichotomy in our world right now between packages and GitHub, and then APIs that are backed by data. So if you think about something like Clearbit or something that returns data to you, and you have these kind of 2 separate worlds that are coexisting. But with Clay and this new serverless paradigm, we actually have the opportunity to revisit a lot of the ways we think about sharing and hosting code. And so in the Clay paradigm, every function actually becomes a living microservice, right? If you think about these static code files, in the case of serverless, there's no reason why we can't just have them hosted up there, and if someone needs to use it, then they can spin up a Lambda and pay for it as it needs to be used, right? And so I'm going to show you now a whois Clay microservice, which essentially just wraps that package we saw. And so this is sort of the equivalent of our GitHub repo page. This is a Clay microservice page. And what you're seeing here is, so under the hood, this is using that NPM package. But what we've done is we've added a little bit of metadata to say, hey, what does this expect? And so what does this service expect? And so in this case, this service expects a domain URL. And I'm able to pass in a domain URL and actually run this function. And so the nice thing is that I'm able to see what was the data that was returned by this, right? So I can actually see, oh, okay, here's the JSON format. Yes, it's pulling up all the sort of information I want. Does it also handle my domain, for example? I can see the logs to access. And so this microservice we're looking at is essentially a AWS Lambda function under the hood that we made super easy to deploy and now access. And so with that, we also have the ability to see the log. So what we do is we make it super easy to deploy these sorts of microservices that then you can use inside of your own application, but also make publicly available so that someone could, for example, use this whois living microservice in their own application very seamlessly, essentially the same way you would use an API. So this whois service that we're playing with right now and passing this parameter to actually lives at a URL endpoint, which you can see over here. And so I'm able to make a curl call to that endpoint, and essentially every repo now becomes an API in this new world. And the benefits of it being an API are many. For example, I can quickly try it out. I can see if it works. We'll talk a little bit more about some of the other benefits that come out when you move from just these static files to APIs that let people access that functionality much more easily. And so the big thing that really we all want to do as software developers is get useful stuff up and running, right? Like that's the end goal, and we happen to have to do a lot of configuration and research on like, oh, okay, is there a good library to do this? Is there a good library to do this? We're trying to cobble things together and then get it to run and be scalable. And so those are the sorts of things that we try to make as easy as possible, right? So let me show you what spinning up a microservice on Clay is like today. So can you guys see that okay? Yeah, it's reasonable. So to spin up a new microservice, all you have to do is install our CLI tool and then write Clay new and the name of the function. So let's say Shutterstock demo. And within a few seconds, this is going to have created a new Clay microservice for me that's going to be living at this endpoint over here. And it's set up some code on my local machine, so I'm able to open that folder up that it created. So I'm going to open up the Shutterstock demo. And I'm going to call Clay open to see the auto-generated repo page that we also make. So all of a sudden, I created a microservice, and it doesn't do anything right now. All this microservice does is it takes in a template, a variable that we just set, and echoes it back to us. And we can see what the code for that looks like. We can open it up over here. And so it's a pretty simple Lambda under the hood. And right now, all this does is it takes in the event variable. So you're able to describe what variables a function should take in using a configuration file that we have, which is a simple JSON file. So in this case, this takes in just a single variable called my variable. It's of type text, and you can describe what it is. And then within your code, you have access to the event variables in an event vars variable. And so in our case, let's say we just wanted it to make it echo something different every time. We would say event vars dot my variable. I think that's what it's called, right? Yep. Equals yay, right? So now we've made a change to this code that we want to get live, and all we'll do is call Clay deploy. And now when I run test, instead it should return just yay. And so it's that easy to get a microservice up and running that's living at an API endpoint, that you can describe what the inputs are, and also have this web interface that makes it super easy to try. And so now we're able to get the microservice up and running that does something useful. We're able to deploy it super easily. And then the next thing is, how do we actually use this microservice that we've created in our code? So, I mean, it's an API, so you could just make straight up post calls to it. In this case, that's kind of what these functions expect. But you're also able to actually install a client library in the language of your choice. And then we make it even easier to actually invoke the function. So in the case of Node, you install the Clay client library, and then you're able to just call clay.run, the name of the function, and then the value it expects as an argument. And so as there are more and more of these little building blocks that are out there, it becomes super easy to write really simple code where you're essentially just invoking these little functional building blocks and combining them together to make more compelling software. So I'll give you some examples of that in a moment. The one last thing I'll say about the benefits of it being an API is that you can write it in one language, right? Maybe you write this microservice in Node or in Python or in Go. And because it's an API, it's all of a sudden usable in any other language using a client library or making post calls from that language. So yeah, so what are the sorts of things that you can do? So by default, all of these repos that we create, they start off as being private, as you can see here, and you can choose to make them public. So very similar to how a GitHub repo works. And the idea that we have is that as people are building their own applications and splitting them up into these little microservices, there's an opportunity to make more and more of these functions public and then have more and more building blocks that we can use to quickly build compelling software. So what are some examples? So for example, here I have a building block that does something really simple. It does a Twitter user search. So I'm able to pass in a name and run it, and it'll try to find users who match that query. So this is essentially just wrapping Twitter's API and giving me a simple way to test it and a simple way to then invoke it in my code by writing clay.run and the name of the function. Pretty simple. And then the next function I'm going to show you is a little bit more interesting in terms of the input types it takes. So this is a function that wraps Google's Maps API to generate a static image. So this one actually happens to take in an address parameter rather than a text parameter, as we've seen. So it makes it super easy for you to get a web interface that actually can autocomplete an address. And so then you can pass that in, and you can see this one takes quite a few parameters in, and run it, and what you get back is a image of the location. And so what I then did was combine that initial whois microservice that you saw, which just does a whois lookup, with that Twitter user search microservice that we just looked at, which tries to find this person on Twitter, and that maps microservice, which tries to then find the static image of the location. And I'm able to now have this new microservice that's a compound building block that I can type in a URL, and it will run. And it takes a second because it has to actually go make that Twitter call as well. But it'll run. It'll return me that whois information that we saw in the first microservice. It'll also return me the Twitter information that it found. And it'll also return me a map URL of that location. And the nice thing is that all of a sudden, this new compound microservice is also available as an API, and you can call it trivially in your code just by calling clay.run. So I built that microservice, and then someone came along and built a React app on top of it. And this React app, all it does is make that, looks like it has a timeout. Oh, there we go. So this is a React app someone made that all it does is essentially provide an interface into that microservice. So under the hood, this makes that one API call. And when I type it in, it just shows that data nicely to the user. There we go. So you can see how having these little microservices makes it much easier to build front ends for these applications as well. And it was really easy for him to build this because all he had to do was make that one API call to that endpoint that returned the data in exactly the format he needed for his application. So I'll show you a few other building blocks just to give you a sense of the sorts of things that we can do on Lambda and on Clay in particular. So I'll look this one up. So this one is a little bit more sophisticated in the sense that this one, what it does is under the hood, it spins up a headless phantom browser and goes to a URL and actually takes a screenshot image of that page after it's given it some time to load. So here I'm able to type, for example, techmeme.com and run it. And this actually took a little bit of setting up to do when I was coding it because I was like, oh, how do I get a phantom browser to run in Lambda's environment? How does all that work? But the nice thing is that now that I've gone through the trouble of doing that, you can just use a you can just use a service that returns you screenshot images without having to think about all of that stuff. So for you now, it's just clay.run, the name of this function, and what URL, the viewport width, the viewport height. But where it starts to get interesting is the fact that now we've also added, just today for the first time, the ability to actually fork these repositories as well, right? So let's say you want to actually fork that microservice I have, which takes screenshots, and tweak it a little bit and do something else with it. So now we have this ability to actually fork a microservice. So for example, let's say I wanted to fork this Google Maps static image one. I can just hit fork on it and hit finish forking. And all of a sudden, I have my own version of this. I can download the code. I can tweak it. But what's interesting is that unlike forking in GitHub, I instantly have my own microservice that's running at an API that is alive, rather than just like forking a repo and then like having to pull it down and doing all that stuff. So the other interesting thing is that we're able to actually fork and parameterize functions as well. And so this becomes particularly interesting when you talk about, like API keys, right? Where, for example, like I need a microservice, but I need it to be parameterized with the API keys that I'm using. So I'll give you an example from GitHub that that shows that a little bit. So let me just open that up in here. So this is a function I wrote, which under the hood uses my GitHub username and password to access GitHub. But when I fork it, right, this thing knows that this function actually needs to use some private function parameters. And so so you can see that right now, because it's my own account, I'm able to actually see these things. But if you fork this, you wouldn't see the values. You would just get the keys that it expects, and you could set your own keys, and then essentially have a parameterized endpoint that makes it super easy for you to then, let's try this out. This is pretty. We're doing this live, but it should work. Yeah, so now this is an endpoint that's parameterized with my GitHub username and password. And so we think that becomes really interesting because it makes it much faster and easier to build applications on existing APIs, and just to get the endpoints you need and the building blocks you need parameterized with your credentials in a private, secure way really quickly. And so for this meetup, for example, I was like, okay, I'm going to build something on top of the meetup API. And so what we had was, first of all, a endpoint that well, let me see. I'll just open it up again. So we had one endpoint that all it does is return the RSVP list for a given meetup. So it respects a meetup ID, and then it returns the RSVP list of that meetup ID. And so these are the results here. Looks like 200 attendees. I don't think there's 200 people here, but that's okay. And then what I have is another one that does a rich profiles lookup. So this one under the hood, you type it in, you give it a name, a username, whatever information you know about someone, and when you run it, it tries to find that person's account on Twitter, on Dribbble, and on GitHub. So something very similar to sort of what Clearbit would do for you. And then I combined that meetup RSVP getter with the rich profile lookup to then be able to actually try to find the social account information of every person who's coming to the meetup. And so now there's this new API building block called Meetup Events RSVP Rich Lookup, which anyone can use, that you give it an meetup event ID, and it tries to find all the information that's publicly available about people trying to find their accounts across different services. And then it was really easy once I had that, to take a basic React app and have it running on Surge, which I should point out is also like another free service that you can just drop a static front-end app and scale seamlessly, and combine that with a Clay endpoint that also scales seamlessly because it's running on Lambda, to then build an application that I only pay for when like it actually gets executed a lot and is almost like a throwaway application, but does something pretty interesting where when I pass it an event ID for a meetup, it tries to find information about the people across all of their social profiles. So that's a sort of demo of how we see the future of, right? So this is kind of what's happening under the hood. We had this RSVP, and then it calls rich profile lookup, which in turn called Twitter lookup, which then called GitHub lookup and dribble lookup. So you're able to like chain these building blocks together to do pretty powerful things quickly. And that's the direction that we're heading in, is making it much easier to build on existing APIs, right? So when you go to most companies' pages, right now the experience is API docs. And that's like tough to get started with. You gotta go grab an API key, you need to spin up a server. We think that we can make a much better experience where instead of reading static API docs, you actually get forkable, runnable examples and a way to build on their API to bring in other useful building blocks and have starter examples that do powerful stuff, right? So like if you come to Meetup's API page, instead of just reading their docs, you should be able to fork this example that I made that pulls in all this data and combines all these different building blocks together as a starting point. So what's next for us? So we are going to continue to make it easy to build on top of these different APIs, and we encourage you all to try to build on one of the APIs that we showcase or to try to put up your own Clay microservice. And we're going to try to start showcasing the most interesting stuff that's being built on the Clay platform. And then on the platform itself, we're adding versioning, which is something that we know is definitely needed to take this into production. And we're adding better logging and testing. So we think we can do a lot more interesting things around the debugging cycle and built-in validation, right? So like if this thing expects an address, I shouldn't have to install a validation library. We should handle that sort of like validation of the parameters to the microservices at the platform level. Yeah, so that's what we're up to. Would love all of you to go and try out the product and either build or fork an existing microservice on Clay. Star us on the GitHub repo. We're sending out updates, and we'll keep everyone up to speed. And also join our Gitter where we're in there. And we just started a form that we'll share out where anyone can request a function, and we'll build a lot of them ourselves. If there's just a microservice you wish existed for your own application, we can help out with that. And so yeah, that's the story. You can find us at clay.run. And thanks again. I guess I should take some questions. Thanks. Right, so we're exploring that. I mean, what I will say is that our thinking is that, so AWS Lambda has a bunch of free tiers where like you don't actually start paying for the Lambdas until they get a fair ton of usage. And so that's good for as a starting base point where you can start actually trying things out. And then our plan is to not charge on top of Lambda, but just to pass through the cost of Lambda to the users. And then there's a question of like who pays it if this function starts getting used like crazy. And I think that that's something that we're still exploring, right? Like in the case of these, if it's a company hosting an API page, maybe they just give a bunch of credits to the developers that come to build on their page. And then if one of those applications is successful, the developer would then pay the cost of Lambda that they were going to pay anyways to power the application. But yeah, that's one of the questions that we need to figure out. And also, you're actually able to test locally as well. I didn't show that in the application, but as you're developing, you can actually call Clay test to have a local development environment where you can try out your code without having it to be in the deployed environment. It's on Amazon. It's on AWS Lambda right now. Right now, that's what we're doing. So the question was, where does this code actually live? What's happening under the hood? And the answer is that this code lives on AWS Lambda. So we're a layer on top of Lambda right now. Similar to how Heroku was a layer on the last set of AWS services, we think of ourselves similarly as a layer on top of Lambda right now. But in the future, we hope that we'll be able to take this function because it's such a simple building block and also distribute it to the other platforms like Google and Microsoft. So you'll be distributed across all the different clouds. Yeah, so we have the same rate throttling that Lambda has, essentially. Not right now, but that's something that I mean we'll explore. Like right now, the way Amazon handles it is that they have like sane limits, and then you can ask them to increase the throttle limits on functions as you need. And so it could be that maybe we do something similar on the Clay platform, where if you're like, this function's going to get a crazy amount of traffic and is liable to DDoS, then you could handle it that way. Yeah. Right, so that's what we're working on right now. So Lambda has versioning under the hood, so we have versions already. We just haven't exposed it into the interface, and then we will need to just think about like when you're requiring a package similar to npm, there'll probably be a way to like specify a specific version that you want to be making API calls to. The nice thing that we can help with is that as people are using these packages, we also are essentially building like an invocation history of like inputs and outputs. And so we can make it easy to essentially build up a test suite that then you can try future versions against and be like, okay, does it still work for all these past invocations that someone sent? Yeah, I mean that's a good question. I think it'll be a question of just like how mature are those platforms, and where do we see more value added to our users, right? Is it to offer distribution across all these clouds, or is it to do more things around the debugging experience and more tools that make it easy to combine the services together? But hopefully not too far away. For sure, yeah. And I think everyone saw that recently with the S3 stuff, right? So we're definitely thinking about that. So, Green, do you want to answer that one? Yeah, so that's one of the infrastructure issues that sort of exists with Lambda right now, is that if you haven't used that function for like a few days, similar to Heroku was doing that as well, right? Like if you didn't visit a site for a while, then like the first time you went to that site took a little bit longer to spin up, and so that's there in Lambda as well, but presumably it'll be solved at the platform level, and there's also ways to get around it. Right, right. Yeah, so serverless, so there's a framework called serverless. It's a good name for being in the serverless space. But so essentially what they are is a set of, I would say like configuration settings for deploying your functions to Lambda, to Google Cloud, to all this. They're not a registry of functions, and they're not, so they're focused more on like enterprise deployments of these Lambda functions rather than where we think of ourselves as sort of like the npm GitHub of all these little microservices that you can pull together and deploy. Yeah, I guess it's kind of like Rails to Heroku is maybe not a bad analogy. Yes. So, so, so the nice thing is that actually you don't have to do a web request. One Lambda can invoke another Lambda. So it's a request, but it's within the actual box. And so we did some like initial back of the envelope calculations and testing around it, and it's definitely slower than like inlining the code directly, but it seems reasonable for a lot of use cases. And also what we've talked about that we could do is actually inline the code, right? So like that's like one possibility that we could consider in the future, where it's like, hey, we could kind of like compile code on the fly and like do that where needed, especially like if something is like doing a really really small thing all the time, and it's probably not a good idea to have that as an API or like even as a call to something else on the box. Yeah, right. That it could be, yeah, and that's something we've talked about, right? So that's one of the things that I think Kareem was mentioning a moment ago. So I think the question is like, hey, for really heavy duty stuff, where I have like a big data pipeline, and I'm gonna need to put it into a queue anyways that I'm acting on, and I'll have to have my own lambdas. How's this going to fit in with that? So one of the things that we could do is push these Clay functions into your AWS account so that then Lambda would act within your account. So then we would be like kind of just the npm registry for installing those into your Lambda account. But yeah, that's
seems like you have a direct dependency with AWS. Do you have a long-term plan to be more agnostic that
Yeah, definitely. Yeah. So I mean, I think that's what we were mentioning before, which is this idea that Google and um, and Microsoft and like also there's like open source implementations of that essential same environment. So the function is like a nice simple building block that we can presumably distribute across these different platforms and make it easy to install it and have it running on all three boxes, right? So it's like, oh, it just your function went down on Lambda, it's okay. It's on Google Cloud, it's on your own infrastructure, it's wherever you need it. Right. Right. So two things. Okay. So the first question was, um, what are the sort of security mechanisms to make sure that one Lambda doesn't accidentally invoke another user's Lambda? And the way that that's done is through like the IAM policies at the AWS level, where if you've kept it private, then that Lambda can't be invoked by another user. And then the to the second question, can you remind me what the second question was actually? Oh, how do we break down pricing? Right. So we log the invocation usage for each of the functions per user. Yeah, that's something we're definitely thinking about, and we have some like ideas of how you can navigate around those issues. But that's definitely a thing. Yeah. Yeah, so we have something that's equivalent to cloning, which is called Clay download. So you can download any function. And then what we don't have yet, and that's kind of what we're talking about and working on, is do we put all of these into a GitHub repo as well? And do people then is there some sort of GitHub workflow similar to what Heroku had, where you can merge and then like push it up to Clay that way? Or do you even need GitHub in this new world? Maybe there's like some subset of the GitHub features that are important to users, and we could just provide those.
sometimes you don't want to write an API? Do you guys have any way of actually porting the existing code the Clay
Into
infrastructure?
Clay. So we don't have that right now. We have played with it a little bit. So right now, something we did was like wrap a lot of npm packages that are out there, and that was pretty easy. But unless your code is like structured as a Lambda already, it would be hard for us to kind of generate a Lambda function profile off of arbitrary code.
Second question, do you plan on having Clay for other platforms like .NET or reusability or just
Right. So the question was, do we plan to support other languages on Clay? And we actually do already support Python. And so we're supporting eventually we'll support what AWS Lambda and these other platforms support. So AWS Lambda now supports Python, Java, Node, and C Sharp.
Yeah, and there's also, I think, if you're interested in that, there's a thing called Apex that lets you, use Go, even though AWS Lambda doesn't support Go. So they like had a shim to do that. And I think it's like something that's interesting for us, like if that becomes one of the things that we want to do, because you can just compile it somewhere else. And Lambda is able to run binaries, so you can compile it, put it up there, and then call it with whatever language.
where does npm install run? So the dependencies
Right, right. So in this, it runs locally right now, but if you list this, you can see it has known modules and it has a package.json file. So this is the function profile. So I can just install whatever stuff I want in here, right? And then do a Clay deploy, and then that goes up with the no modules and everything.
and deploy uploads everything, all
Yeah, up. It sends up the whole
That's actually one thing that we've been working on is trying to make that faster.
Yeah, so right now, yeah, we could just be sending the diffs. We could do, I think, which is what you might be hinting at, is the fact that we could just be doing the npm installation up on our platform instead. Theoretically. Yeah. Right. Right. Yeah. So that was one of the like initial frustrations with Lambda too, was that it was like a pain to like you had to deliver zips up. You had to like install your stuff and then turn it into a zip and upload that. They've made it a little bit better now, but it's still, and that was one of the big problems that serverless was trying to solve as well, where you have dependencies across projects and you want to upload them reliably. Yeah. Okay, one last question.
What about npm modules that require binary compilation for platforms?
Yep, right. So, I mean, so it can be done. Like that Phantom.js thing I showed, what I had to do was I had to find a binary that ran on Amazon's infrastructure. And then, and then once it ran, though, then I could use the npm library. But the nice thing is that now you can just fork that, and you already have the binary that's compiled correctly for the Amazon service. Okay, one last one. Not right now. The question was, can you set up multiple endpoints for a Lambda function? We don't have that ability, but something that we do want to do is for every function that we spin up, you'll have a dev, test, and production environment. That seems like something you'll probably need. We'll need to have that going forward.
You can kind of, you can basically achieve that today by creating it and forking it and calling it like dev version, but we want to do that automatically.
Yeah.
Just one strategy. There are a couple strategies to use the Lambda function. Is the one-to-one mapping, one endpoint. Some people use it as Lambda as microservices. So basically, one function can fulfill multiple functionality.
Right. Yeah, definitely. Like essentially putting like an entire monolith with like multiple endpoints within that one Lambda.
That would be the third strategy, the monolith.
Right.
Microservice is not a monolith.
Right, it's not a monolith, right.
And it helps with the cold starts because you have multiple endpoints hitting the same Lambda, so you have less chances.
That makes sense. I see what you're getting at. Yeah, so like having like lots of API endpoints that point to the same one Lambda that actually is a couple of microservices, right? Yeah, we're not doing that right now, but that's definitely interesting. And what I'll say is we are very early on, and we'd really love feedback and any thoughts you have. I mean, it's definitely a new paradigm, so there's things to be explored and figured out in terms of how all of this works in practice. Yeah, great. Thanks so much.